Article 408.16 of the National Electrical Code states that where branch circuit fuse or circuit breaker is to be selected to protect the conductor's size required by Article 210.19a, such selection shall be based on the minimum branch circuit rating permitted. Article 430.72d states that where the distribution panel board supplies a feeder or branch circuit without a protective device, circuit breakers or fuses shall be provided to protect the conductors. Section 6.74.1 of NFPA 79 states that disconnect switches shall be capable of interrupting their rated current. Section 13.3.4 of NFPA 79 states that where a switch is used to disconnect a feeder over 600 volts, it shall be fused or provided with a current limiting device. Section 10.8 of UL 508 states that circuit protection shall be provided for all conductors. Section 10.82 of UL 508 states that fuses shall be used where there is a possibility of overloading or short-circuiting. Based on these code references, it is a requirement to provide fusing for disconnect panels. The plant bus plugs alone do not provide sufficient protection for the panel wiring. Firstly, let's delve into the NEC, the National Electrical Code, and examine how it addresses the protection of conductors within control panels. Article 210.19 is a cornerstone, as it dictates the minimum size of branch circuit conductors. The code emphasizes that the ampacity of these conductors must not be less than the maximum current to be served. This ensures that the conductors can safely handle the intended load without overheating or posing a fire hazard. When selecting a branch circuit fuse or circuit breaker to protect these conductors, Article 408.16 provides crucial guidance. It mandates that the selection must be based on the minimum branch circuit rating permitted. This means that the overcurrent protection device, whether a fuse or a circuit breaker, should be sized appropriately to protect the conductors from overcurrent conditions while allowing the normal operational current to flow without unnecessary tripping. Secondly, Article 430.72d further reinforces the importance of overcurrent protection. It specifically addresses scenarios where a distribution panel board supplies a feeder or branch circuit without a protective device. In such cases, the code unequivocally states that circuit breakers or fuses must be provided to protect the conductors. This provision is essential to prevent damage to the conductors and equipment in the event of a fault or overload condition. Let's shift our focus to NFPA 79, the electrical standard for industrial machinery. This standard provides requirements for the electrical design, construction, and safety of industrial machinery. Section 6.7 focuses on control circuit devices and components, including disconnect switches. Subparagraph 6.74.1 states that disconnect switches shall be capable of interrupting their rated current. This requirement ensures that the disconnect switch can safely interrupt the flow of current under normal and abnormal conditions, preventing damage to the switch and other equipment. Section 13.2 of NFPA 79 addresses supply circuits and wiring. Subparagraph 13.23.4 specifically addresses switches used to disconnect feeders over 600 volts. In these high-voltage applications, the code mandates that the switch must be fused or provided with a current limiting device. This requirement is crucial to protect the switch and downstream equipment from the potentially severe consequences of high-voltage faults. Thirdly, let's turn our attention to UL 508A, the standard for industrial control panels. This standard provides requirements for the design, construction, and performance of industrial control panels. Section 10.8 of UL 508 is dedicated to circuit protection. It states that circuit protection shall be provided for all conductors within the control panel. This overarching requirement emphasizes the importance of protecting conductors from overcurrent conditions to prevent damage and ensure safety. Section 10.82 delves into the specific use of fuses for circuit protection. It states that fuses shall be used where there is a possibility of overloading or short-circuiting. This provision recognizes the effectiveness of fuses in providing reliable overcurrent protection in a variety of applications. When considering whether plant bus plugs provide sufficient protection for panel wiring, it's important to understand the limitations of bus plugs. Bus plugs are typically designed to protect the busway itself and the equipment connected directly to the busway. They may not provide adequate protection for the smaller conductors used within control panels. The current ratings of bus plugs are often significantly higher than the ampacity of the conductors used in control panels. This means that a fault within the control panel may not trip the bus plug, potentially leading to damage to the panel wiring. Fuses, on the other hand, can be selected with current ratings that are closely matched to the ampacity of the conductors they protect. This allows fuses to provide more precise and effective overcurrent protection. In conclusion, the NFPA 79 and UL 508 all emphasize the importance of providing circuit protection for conductors within control panels. Fuses are a widely recognized and effective means of providing this protection. Plant bus plugs alone may not provide sufficient protection for panel wiring, and supplemental fusing should be considered to ensure compliance with applicable codes and standards. It is always advisable to consult with a qualified electrical engineer or inspector to determine the appropriate level of circuit protection for a specific application. Let's break down each of these points further to ensure a comprehensive understanding. First, regarding the NEC or National Electrical Code. The NEC is a widely adopted standard for electrical installations in the United States. It provides comprehensive guidelines for safe electrical practices, covering everything from wiring methods to overcurrent protection. The NEC is updated every 3 years to reflect advancements in technology and changes in safety requirements. Secondly, regarding NFPA 79, this standard is specifically tailored to the electrical systems of industrial machinery. It addresses the unique challenges and requirements associated with industrial equipment such as machine tools, robots, and automated systems. NFPA 79 covers a wide range of topics, including control circuits, power circuits, grounding, and safety interlocks. Understanding this will help you with industrial machinery. Thirdly, regarding UL 508A, this is the standard for industrial control panels. It provides requirements for the design, construction, and performance of control panels used in industrial applications. UL 508 covers topics such as wiring, overcurrent protection, component selection, and environmental considerations. UL 508 certification is often required for control panels used in the United States. As you can see, each of these standards plays a critical role in ensuring the safety and reliability of electrical systems in various applications. Compliance with these standards is essential to protect personnel, equipment, and property from electrical hazards. Furthermore, overcurrent protection is a fundamental aspect of electrical safety. Overcurrent protection devices, such as fuses and circuit breakers, are designed to interrupt the flow of current in the event of an overload or short circuit. This prevents conductors from overheating, which can lead to insulation damage, fires, and other hazards. The selection of appropriate overcurrent protection devices is crucial to ensure that the conductors are adequately protected without nuisance tripping. A fuse is a simple and reliable overcurrent protection device that consists of a metal element designed to melt and interrupt the circuit when the current exceeds a predetermined level. Fuses are available in a wide range of current and voltage ratings to suit various applications. They are relatively inexpensive and easy to replace. A circuit breaker is an electromechanical device that automatically interrupts the circuit when an overcurrent condition is detected. Circuit breakers can be reset after they trip, making them more convenient than fuses in some applications. Circuit breakers are available in a variety of types, including thermal, magnetic, electronic, and solid state. Also, it is important to understand that busways are a common method of distributing power in industrial and commercial facilities. A busway consists of a series of conductors enclosed in a metal housing. Busways offer several advantages over traditional wiring methods, including ease of installation, flexibility, and high current carrying capacity. Bus plugs are used to connect equipment to the busway. They typically contain overcurrent protection devices, such as fuses or circuit breakers, to protect the connected equipment. When it comes to conductor ampacity, this is the maximum current that a conductor can carry continuously without exceeding its temperature rating. Conductor ampacity is determined by factors such as conductor size, insulation type, and ambient temperature. The NEC provides tables of conductor ampacities for various conditions. Moreover, short circuit current is the maximum current that can flow in a circuit under short circuit conditions. Short circuit current can be very high, potentially causing significant damage to equipment and conductors. Overcurrent protection devices must be able to interrupt the short circuit current to prevent damage. To summarize, it is crucial to ensure that the conductors are adequately protected from overcurrent conditions to prevent damage and ensure safety. Fuses are a widely recognized and effective means of providing this protection. Plant busplugs alone may not provide sufficient protection for panel wiring, and supplemental fusing should be considered to ensure compliance with applicable codes and standards. Always consult with a qualified electrical engineer or inspector to determine the appropriate level of circuit protection for specific application.